Well, good morning, everybody. It's a nice cold day, windy here in the land of enchantment. I want to apologize about Friday. For some reason, my microphone got turned off. Today, I want to talk about science predictions. And no, it's not voodoo, it's not some kind of magic. My joke of the week, a scientist friend of mine started to become a psychic, but gave it up. Prediction in research. To a certain extent, most scientists regularly use prediction in research as a fundamental of the scientific method, which we all hear about constantly. When they generate a hypothesis and predict what will happen. These predictions can have wide-ranging effects and direct whole science disciplines, such as with relativity and with evolution, which have underpinned research in physics and biology for many years. On the other hand, smaller experiments can also have wider ramifications and allow humanity to predict and therefore avoid future events. So here are some examples in medical research. One of the earliest examples of this was the Muslim scholar Al-Razi. He was asked to find the best location to build a hospital in the city of Baghdad. Cleverly, he hung a piece of meat at each potential place, and his prediction or hypothesis was that the place where the meat took the longest to rot would be the best place to build a hospital. Note that he used the scientific method. So he was given a question, where's the best place to build a hospital? He created a hypothesis that the place where meat took the longest to rot would be the best place to build a hospital. He did an experiment. He hung a piece of meat at each place, and then he did his experiment. He took data, and his results were where to build the hospital. So definitely the scientific method. Here's another. To determine the amounts of a new medicine, medical researchers will run experiments with multiple independent variables, such as weight, age, general health, health history, and the severity of the illness, so on and so forth. And using statistical methods, they can predict the amount of medicine to prescribe to a patient. Similar experimentation to this and statistics can help researchers predict causes of diseases. So like if they were doing a study on lung cancer, they might do some experiment or collect some data, and they found out that smoking was a major cause for lung disease, and they also found that it didn't account for all of the variability, so they did other researches to find other causes. In physics research, one fine example of making experimental predictions and generating hypotheses was the work of J.J. Thomson, who conducted a wonderfully innovative series of physics experiments by making predictions. After he completed an experiment and he got his results, showed that the prediction had some basis and fitted the observations, he made another prediction, and he worked toward a greater goal in stages. So he refined his model over and over to make it a better model. Physicists also work at the other end of the scale and make huge predictions that are capable of shaking the world of science. And of course, we already talked about Einstein, and you could also mention Newton, Hawking, and these theoretical physicists. Some of the biggest proponents of prediction in research are the theoretical physicists such as Einstein and Hawking. They use sweeping and elegant mathematical theories to predict how they think the universe behaves. So they're on the extreme far end. Their predictions actually guide the direction of entire scientific paradigms, as the empirical physicists test and attempt to falsify parts of the theory, leading to refinement and change. So they made some wide sweeping observations, and then other physicists took up the baton, and they're doing the actual research. Another example is in astronomy and astrophysics. Astronomy has thrown up some great examples of prediction in science, largely built upon the laws of motion proposed by Newton. One of the finest examples of this arises from the discovery of the planet Neptune, which stands as a testament to the skill of the astronomers, but also to the work of Newton. The discovery of this planet showed that his work is largely correct under most circumstances. So the theory of relativity explains physics at the extremes of scale. So at the extreme large and at the extreme small, and close to the speed of light. So that's the theory of relativity. Newton is in the center in the normal day-to-day scales. The planet Uranus, discovered by William Herschel in 1781, had made nearly one entire revolution of the sun by 1846. Excited astronomers realized, after looking at star charts, documenting the progress of the planet, they realized that its orbit was irregular and did not follow the Newtonian prediction for planetary moment. They predicted that the only possible explanation for this was if the planet were under the influence of another large planet lying further out, exerting a gravitational pull. In Britain and in France, astronomers set out to predict the position of this new planet, and then find it, which they did. So this was long before computers, and you can imagine how tedious it was to try to find that new planet. The dwarf planet, Pluto, was also discovered using analysis to predict its location, and then experimental examination, again without computers, to find it on photographic prints. Measurements of its change in position allowed researchers to predict its rotational trajectory. So this guy, Clyde Tombaugh, took these large photos of the sky, and he would compare them, flip one up and flip it back and forth to see the movement of sky of stellar objects. And that's how he found Pluto without any computer methods. So using similar methods, we can predict astronomical events past and future, such as eclipses, comets. We found other dwarf planets. All of these things have been done by astronomical predictions. Even in archaeology, prediction and research, strangely enough, even an intuitively backward-looking discipline such as history uses prediction and research. Most historians state a thesis, the equivalent of a hypothesis, and set out to find evidence in support or deny it. One of the greatest examples of this was the adventurer and proto-archaeologist Harold Schliemann. He firmly believed that Homer's Iliad gave geographical clues and measurement that would allow him to find the site of Priam's Troy. Patiently, he collated the information. He raised funding, which flat earthers don't seem to want to do. Before setting off, he used the Iliad as a roadmap. He found a ruined city that most academics believe is Troy, and his prediction was supported. Just as a side note, his archaeological methods were crude and destructive, but nobody can fault his detective work and power of prediction. The rise of predictive science. So much of the current rise in exponential growth in computing power, which allows gradually more detailed and accurate models. These are of great use in predicting weather or natural disasters such as earthquakes and tsunamis. It takes some serious computing power to try to predict weather. There are so many variables and so much variability that it's very difficult to predict. I did want to make one comment here. I've seen simulations of weather where they predict what's coming. I do know about simulations, and if the earth were flat and motionless, trust me, the simulations would be practically impossible to do. You would have to have border conditions for when it runs into the ice wall, so things like that. So it just would add to the complexity of weather predictions. In computer design, maybe you guys have noticed Markov chains, which is mathematics, are used to predict the next words in text editors and relative advertisements or relevant advertisements. So I don't know if you've noticed, I have in Gmail that you type something in and it predicts the next 2 or 3 words that you're going to type. With millions of dollars invested by governments or by oil companies using the predictions of geologists to know where to drill wells. And yes, I noticed that it's investments by governments or big companies. What can you say? You have to go where the money is. Predictive science is only going to grow. However, this entire field of science and computing rests upon the same foundations that drove early scientists. The principle of making a prediction and setting out to test it. Unfortunately, these predictions in science are at the whim of these paymasters such as the government or private sector. But prediction and research is always going to drive the scientific method, and where we spend money to further the research. So back to my joke of the week, guys. A scientist friend started to become a psychic, but gave it up. He couldn't see any future in it. Get it? He couldn't see any future in it. So I hope you understand what I'm saying about prediction in science. There's a lot of stuff coming. You can imagine as computers get more and more powerful, there will be more and more advancements in science from that. Stay tuned tomorrow for This Is Your Life. And then instead of Friday, I'm going to do a special video on Thursday for Halloween. So stay tuned for those coming up, and we'll see you then.